Unit 10, graphing. Let's go. Sketch the following by hand. Use your formula sheet to find and label your important details. All right. Now, I don't even have a formula sheet, but I'll build one for you and make sure to add it to this packet so that you have it. But I look at this, and I see I got squared stuff minus squared stuff. Immediately, I know this is a hyperbola. Also, the formula that goes with that is a squared plus b squared equals c squared. And once I know it's a hyperbola, I lock into my system. Number one, find the center. -3, 1. There's my center. 1, 2, 3, 1. So, I like to draw in a brand new XY axis. You guys are probably sick of me talking about that. But there's my new origin. -3, 1. Very significant. So now, what is that? Well, that's a squared. Why? Because it's bigger? No, because it's first. You got to be able to separate that from ellipses. So I take the square root and I get 4. What does that mean? It means I travel along the x direction 4 from here. 1, 2, 3, 4. 1, 2, 3, 4. Now I know this is b squared, so b squared is 9. Take the square root, I get 3. So I travel along the y-axis 3 units. So 1, 2, 3. 1, 2, 3. Sorry. Build the box. And why do we build the box? To draw in our asymptotes. So there they are. Perfect? No. Pretty good? Yeah. Well, because it starts with x squared, that means it's going to be 2 Pac-Men eating the x-axis, which means this is the vertex, this is the vertex. So that's going to go like this. I shouldn't have touched it, but I did. This, this, and this. Now, what's the important information I'm interested in? Well, those are the vertices, but, which we could just say, important details. So if they ask for the vertice, that would be 4 units to the left of center. So that point right there would be -7, 1. That point right there would be 1, 1. And there's my vertices. Now, where's the foci? Well, the foci are out here. Just like parabolas go around the foci. That's what these are, basically. That's where this formula comes into play. So a squared is 16. B squared is 9. C squared, so that's 25 equals c squared. Take the square root, and I get essentially plus or minus 5, which means go left of here 5 units. So remember, my center is -3, 1. I need to go left of this 5, which would take me to -8, 1. And I need to go right of that 5, which would take me to that spot. Which, yeah, so wait a minute, -8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so that would be right there. That means this one would have to be right there, which is 5 to the right of that would be 2, 1. I don't know why that was such a struggle for me, but it was. So there's my foci. And that's good. All right. Let's go on to this one, number 2. I can see y is not squared, x is. So this is going to be a y equals ax squared kind, which means it's going to go up if a is positive, down if a is negative. Well, let's reverse this thing so it lines up the way we've been used to seeing it. Now we're going to multiply that by -1, 4. We could divide by -4, but that would throw us off. Remember, we need an a for parabolas. So this works out better. So this hits this hits this. So we get y equals -1/4 x plus 2 squared. What does that tell me? Well, there's an adjustment in our vertex, left 2. Also, it's going to be one of these. So there's no adjustment in my y because I don't have anything here and I don't have anything joining the y. So all I got to do is go left 2. There's the vertex. Because it's negative, it's going to be a sad face, and that means it's going to be relatively wide. Vertical shrink. Now, if you know it's wide, make it extra wide, just to really communicate that on your test. Well, we're not done. We got to find the directrix, which is the soil. We got to find the focus, which is the pistil. So, where do we get that? This is where the formula A equals 1 over 4C comes into play. A is 1/4. Why did I ignore the negative? Because we're trying to find C. What's C? That's a distance. So really you can ask yourself, 4 times what is 4? Well, C is 1. So I know I need to go up here for the soil. So my directrix is y equals 1. Focus is going to be down 1, which if this is negative 2, 0, this is negative 2, negative 1. And that's it for the parabola. All right, what do we got here? Well, it appears we have a circle. Notice, this is over 1, this is over 1. So this is a perfect ellipse, i.e. a circle. Well, find the center. Negative 4, 1. 1, 2, 3, 4, 1. This is equal to r squared. So I take the square root to find r, and that's 4. 1, 2, 3, 4. 2, 3, 4. 1, 2, 3, 4. And then just do your best to draw it in there. I'm pretty proud of that circle. All right, let me pause that. Number 4. Notice, if you took away the 4 and the 16, we'd have x squared plus y squared equals 64, which would be a perfect circle. We obviously have a wacky circle, which tells us it's an ellipse. And then the formula a squared minus b squared equals c squared should jump into our head, or you can use your formula sheet. And we know that ellipse has to equal 1. So we're going to divide by 64, divide by 64, reduce. That's 1/16, so it's x squared over 16. That's 1/4, so it's y squared over 4 equals 1. This is an easy one because the center is 0, 0. Well, what do we do with that? Well, the biggest number in the denominator is our a squared, so a is 4. Smallest numbers are b squared, so b is 2. What does that help us do? We got to travel along the x-axis 4 units. 1, 2, 3, 4. 2, 3, 4. Got to travel along the y, 2. There's 2 and 2. Now, what's the important information that travels along with an ellipse? Well, these are the vertices. So that'd be negative 4, 0, and that would be 4, 0. And that'd be 0, 2, it's a 0, and that point right there is 0, negative 2. What else do we got left? Well, we got some foci in here that we need to find. Foci are always on the major axis, and this is important. So, we're going to use that formula. A squared, which is 16, minus b squared, 4, equals c squared. So we get 12 equals c squared. Bada boom, bada bing. If we broke that down, it'd be 4 and 3. So it's 2 square root of 3. Now remember, we got to move left of center that far and right of center that far. So that would just be plus or minus 2 square root of 3, comma 0. That would be my foci. Now if I actually figured it out, it'd be 1.7 times 2, or approximately 3.4, which would be 1, 2, 3, a little bit in here, and a little bit in here. I know that gets messy, but as long as you have it written somewhere, I'm going to give you some grace there, because that's obviously a mess. Now, here comes some story problems. Every picture tells a story. Find the equation in standard form for each of the following. A circle. So instantly, we know the generic formula is this. The center's -1, so we got to adjust the x value -1. So that's x plus 1 squared plus, up 3 means -3 squared. Now here's a little twist. Radius is square root of 11. Remember, we got to square the radius. So what is the square root of 11 squared? 11. We just found the equation. All right. Now they're going to get wordy with us. A hyperbola with transverse axis. Now what is that? Well, here we go. With endpoints blah, 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 blah. Let's get a little picture here. So I'm going to do this up here because there's a little more space, it seems. So 5, 3, 1, 2, 3, 4, 5. I should have provided you with a graph, but I didn't. -7, 3, 1, 2, 3, 4, 5, 6, 7, 3. Now what is that? Well, the transverse axis is the axis where the hyperbola, which essentially are two parabolas, are going to take off like that, which is big. But now we got to find the center of these 2 points. So if this is -7, 3, and if this is 5, 3, that means we've got 12 units in between here. That means I can go 6 from here or 6 from here, which would take me to that point right there, which is -1, 3. Now, because the Pac-Men are eating the x-axis direction, that means my x is going to come first, but it shifted, the center shifted 1 to the left. So I go x plus 1 squared over, I know there's an a squared down there, minus y up 3, so -3 squared all over b squared. And we know it always equals 1. All right. Well, we know that this distance, we already talked about it, was 6. And that is my a, because that is the axis that the vertices are on. So if that's a and I square it, I get 36. So I could erase that and just put a 36 in there. Here's a clue. Conjugate axis. That means if we were to build a box from our center, the whole axis is length 10. So we'd go up 5 and then down 5 to build our box. But it doesn't say to graph it. It says find the equation. So if that's 10, then b equals 5. And if we square that, what do we get? 25. So we're going to take that out, put a 25 in there, and now we have the equation of the hyperbola. There's a lot going on there. Let's go on to the next one. An ellipse. Remember, this has got to equal 1, just like a hyperbola, but let's get that picture going. Center is 4, -2. 1, 2, 3, 4. 1, 2. There it is. Focus is 4, 4. This is interesting. Tells us a lot. So the focus in an ellipse is always on the major axis, which is a huge clue. But let's go ahead and put that in there. So that's 4, 4. And that right there is 4, -2. What does that tell us? Well, it tells us C. So that distance right there is 6. From -2 to 4 is 6. So I know C is 6. And that's going to be helpful. Now it says the major axis has length 20. That means I cut it in half is 10, which means from the center I would go up 10. So here's up 6, 7, 8, 9, 10. So what does that mean? Well, now I need to go down 10 from here. I don't know if I'm going to squeeze it in there, but that's -2, 3, 4, 5, 6, 7, 8, 9, 10. I just made it happen. So my ellipse is starting to look like this. But remember, they're not asking us to graph it. They're asking us to find the equation. But here's a generic drawing. So now I know that A is 10. I know it's longer along the y-axis, which is telling me that a squared is going to go under the y. Now, don't forget, this is my center. So there's my x shift, there's my y shift. So this is going to look like this. X minus 4 squared over b squared, the smaller axis, plus y plus. That's an ellipse. Y plus 2 squared over, now remember, this is my a squared. Well, I know a is 10, so I can put 100 right there. Equals 1. Now, how am I going to find b squared? Is it right here? Do I use the drawing? No, I just threw out a random drawing. This is where the equation a squared minus b squared equals c squared is going to be our best friend. A squared we know is 100. B squared we're trying to find. C squared would be 36. So if I subtract 100 from both sides, I would get negative b squared equals negative 64, which means positive b squared equals positive 64. Now I know you want to take the square root, but look, we need b squared, and we got it. It's 64. And we have discovered the equation of that ellipse. All right, I'm going to go ahead and call that the end of part 1, because YouTube just has an easier time processing videos less than 15 minutes or around 15 minutes. So we'll see you for part 2. If you like the video, like and subscribe. I'm trying to go viral. You know it, you guys.